Okay, surface areas and volumes of similar solids. Now this time we're doing a 3D, whereas before it was areas of similar figures, which was 2D. All right, let's start. If the matching sides of two similar solids are in the ratio 1 to k, then their surface areas are in the ratio of 1 square to k squared, which is just 1 to k squared, and their volumes are in the ratio of 1 cubed to k cubed, which is 1 to k cubed. Now, that was when it was just 1 to some number. What if it wasn't 1? Now, if the ratio was m to n, the surface areas will be m squared to n squared, and the volumes will be m cubed to n cubed. So we can write these ratios into fraction form. Just remember to write it in order. If it was there will be a bigger surface area and a smaller surface area. So whatever you start, you need to keep up with the order. Same as the volume. Okay, so let's start the question 1, and you will see what I was trying to tell you about that. Okay, so I'm just going to push it all down. Good. Okay, so question 1. For these two similar triangular prisms, find the ratio of their surface area and volumes. Okay, so how are we going to do that? Surface area, I'm going to push up a little to do this. Okay, that's better. Now, first thing first, we need to have a ratio of sides. Okay, so whatever you do, you try to find the ratio of sides first. Okay, and then from that size, you can do surface area or volume. Okay, depends on the question. So ratio of the sides A to B. So that will be, you can pick any. There's a 3 sides here, 3 sides here. I'm just going to pick 3 and 6 here. So I'm going to go 3 to 6, which I can simplify into 1 to 2. So it's like sort of doubled up. Okay. Now, since I've got the ratio of sides, I can do ratio of surface area. The SA stands for surface area. So ratio of the surface areas will be 1 square dot 2 squared, which is 1 to 4. And of course, I'm just going to push up. Ratio of volumes is the same, but except 1 cube to 2 cube, which is 1 to 8, because 2 times 2 times 2 is 8. So that's what the ratio of volumes for these prisms. Okay, so next question, question 2. Two similar cylinders have their surface areas. Now this time it's not sides, it's areas, in the ratio of 16 to 49. If the volume of the smaller cylinder is 160 centimeters cube or cube centimeters, find the volume of the larger solid in 1 decimal place. Now I'm just going to sketch this first so that I can visualize what it looks like first. So I'm just going to quickly sketch a smaller one first, and then larger one. Okay, so I'm going to call the first one as A, second one as a B cylinder. And what was it? A smaller one, we had volume of 160 cubic centimeter there, and B we don't know. All right, so and what else we've got? We have a surface area. So ratio of surface areas is 16 to 49. Now that's supposed to be m squared to n squared because it's surface area. So we need to find a ratio of sides. Now to get to m and n, you just have to do square root of these areas, ratio of areas, and only takes positive, guys. So it'll be 4 and 7. So that is your ratio of sides. Now we are ready to do the volume bit. So therefore ratio of volumes will be 4 cube to 7 cube, which will be 64 to 343. Just free to use calculator on this one. Now that's not the answer. We have to find the volume, not the ratio of volumes, volume of larger solid. Okay, so what we got here is let volume of the larger solid equals VB. Okay, volume VB. So now we need to put it into the ratio part. So I'm going to put my unknown first over. Okay, so what's happening here is VB over the smaller volume. I'm going to deal with the volumes here first, equals the ratio. Now I put the bigger volume on the top and the smaller one on the bottom. So my ratio should follow that order. So I'm going to put the bigger one first, 343, bigger parts of the ratio, over smaller part, 64. Remember, keep that order, okay? Otherwise you might not get the correct answer. So I'm going to push that up. So now we need to find the VB, which is, I'm just going to times by 160 on both sides. I'll get volume for B equals 343. 64 times 160. Just simply use a calculator. You will get 857.5 cubic centimeters into one decimal place. Okay, so that's question 2. Now question 3. There are two similar, okay, this is another sort of a cylinder question, cylindrical drink cans. The larger can is 15 centimeters high and contains 350 milliliter of drink. If the smaller can is 9 centimeters high, how much drink does it contain? Now, question is asking you to find the volume of the smaller drink, okay? So, first thing first, okay, it's in a centimeters, volume, cubic centimeter, which is 1 cubic centimeter is the same as 1 milliliter. So if we can find the volume, we can just convert it to capacity. Okay, so it's not a big deal. Now, first thing, I just like to sketch first so I can visualize what's happening in my head. So, big can and a small can, A, B. Now, the 15 centimeters high for the big one, and 9 centimeters for the small one. And then the volume for the big one is 350 milliliter, and the small one, we don't know. Okay, so what's the question? We have to find the volume of the smaller drink. Okay, so first thing first, what we're going to do, we need to find ratio of side. In this case, is the height. Okay, so ratio of height. Heights is, and then I'm going to do A to B from here to here. So that will be 15 to 9. Now we can simplify this one, divided by 3, so it'll be 5 to 3. So that's the ratio of the heights, sort of like a ratio of sides. Now from here, we can go volume, surface area, but in the question, it says volume. So we're going to do the volumes, yeah, of volumes equals, I'm going to go 5 cube to 3 cube, which is 125 to 27. Okay, and then we need to find volume of the smaller one, so using this ratio. So what I'm going to do is let the volume of the smaller can be VB. Okay, so now we need to write it in the ratio form. I'm going to put unknown on the top. Now I've got the smaller volume first, and so I'm going to put the large one underneath. 150 milliliter equals, now with the ratio I need to write smaller one first and then the large one the last, because my unknown is smaller, so the order is important. Okay, so it'll be 27 over 125. So do not write it the other way around, but just because we got here doesn't mean 125 over 27. It depends on which one is coming first on the top, on the left hand side. And of course I want to make V be the subject, so I'm going to times by 150 on both sides. So it'll be VB equals 27 over 125 times 350, and use your calculator. You will get 75.6 milliliter. Okay, so that's the answer. Okay, the last question is a spherical balloon has a radius of 10 centimeters. By what factor? Now here, what factor is what number you multiply. Okay, that's what it means. It could be just a value, could be a fraction. Okay, most likely fraction because we're dealing with the ratio here. Is the volume decreased if the radius changes to 8 centimeters? It said decrease, so it means the sphere, like the balloon, will be getting smaller. So I'm just going to sketch this. So it goes from big to small here. So it was 10 centimeters and then it just changed to 8 centimeters. That's what that meant. Okay, that's all. That's all that was. Okay, nothing special. So again, we just have to find the radius of sides. It just happened to be its the ratio of the side, which is the radius, and there's two of them, so we call it radii. So ratio of radii A to B. So I'm going to call this A, I'm going to call this one B. So that will be 10 to 8, which will be 5 to 4. Okay, just half them. And then from here I can go volume, surface area, but here we are going with volume because question says volume. So ratio of volumes equals 5 cube to 4 cube, which is 125 to 64. Calculator will be wonderful if you can't do it in your head. That's perfect. Okay, so now we can say factor is, now is it 125 over 64 or 64 over 125? Now you need to think carefully here. The question says it's decreased. So when it says decreased, you want to be, smaller in that. So to be 64 over 125, not 125, 64. That will be increased. Okay, so your answer should be here is there has been A, 64 over 125, decrease in the volume. Now, we can check this one if you wish. So I'm going to check this one because I'm not really 100% sure about this. So I'm going to check. Okay, so volume of sphere is what, formula of the volume of the sphere is what, 4 over 3 pi r cubed. Okay, so, and it's going from volume A to volume B. Okay, so volume A will be what, 4 over 3 times pi times 10 cube, isn't it? Volume A, because sphere A is bigger. And then times by this factor, 64 over 125, should be equal to volume B. Okay? Because that's what we said. By timesing 64 over 125, the sphere reduced, okay, with a radius of 8. So let's have a look. I'm just going to write this in a pi form, just easier, and the volume B should be 4 over 3 times pi times 8 cubed. Okay, we don't have to times the factor because that's the result. Okay, volume B is the result. So if I do that, and then my calculator, my trusty calculator right there, turning it on. So I'm going to do this, 4 over 3 times, move this one a bit, yep, 4 over 3, I'm not going to do pi, I'm just going to doing the exact one, cube, times 64, 125. Okay, so that's what I've got here. I've got 2048 over 3 pi is what I've got for big sphere balloon, and small one is 4 over 3 times 8 cube. There you go, it's the same. So we can say this factor that we just times it is correct. Excellent, well done people.